Yeah.
This is group 6 for CNST 6308, data analysis and construction management. The topic that we chose is deep learning with image analysis, and we are going to present our project in construction installation equipment detection. We have 5 members: Bruno Camargo, myself, Balaji Sankari, Vikas Manti, Navin, and Siris Sharam. Now I'm going to hand over the introduction to my colleague Siris Sharam.
Uh, Thank you, Bruno. Hi, my name is Sri Charan. I'm from Group 6. Our topic is on deep learning with image analysis. This is our introduction. These are our topics. Want to detect the equipment installation in an FPSO, and why there are so many equipments or sensors in an engine room, and the image analysis can help to describe whether the area is completed or not, and how to use image analysis algorithms, uh, and where in an FPSO or engine room where it is used, and at which time, during construction and area completion, and who is the responsible, who are the members that install cameras in an strategic spots. And further is continued by Navin Reddy.
Hello everyone, I am Navin Reddy from Group 6. Today my topic is about FPSO engine room. It stands for floating production storage and offloading. It is a drifting creation, offloading and stockpiling. It is an example of stockpiling and unloading during drifting creation. The seaworld industry makes extensive use of the boats which have evolved into one of the essential methods for managing and accumulating oil and gas. A floating production and storage facility at sea or FPSO is a drifting vessel that serves this purpose. Oil and gas companies typically use and rent them. Next, and these are the decks we have used in our engine room. Like we have fourth desk, fifth desk, and sixth desk. In fourth desk, we have hydraulic wall panel, firewater hydraulic vessel. In fifth desk, we have freshwater cooler heat exchanger A and B, and we have freshwater cooling pump A and B, oil water separator. In sixth desk, we have diesel oil pressure, engine room service pump, 5 watts lift pump, engine room ballast pump, hydraulic wall panel, engine room, 5 watts IG cooling pump, firewater jockey pump, and seawater filter. The data of equipment came from the following equipments, and it is going to explain by our groupmate Balaji.
Hi everyone. These are the type of equipments we are gonna use. Pressure vessels. A pressure vessel is a capacity tank or vessel that has been intended to work at a pressure of over 15 psi. Late reviews of strain vessels have shown that there are an extensive number of broken and harmed vessels in the work environment. Broken and harmed vessels can bring up spillage or break disappointments. Those can cause us suffocations, flames, blasts, risks, and etc. Next one is the pumps. Pumps are mechanical devices that force air into tires or inflatable items by employing suction or pressure to lift or to transport liquids, compress gases, or do both. These are the images of the pumps. The next one is heat exchangers. So these system used to transfer heat between source and a working fluid. These are the images of the heat exchangers. Pressure gauges. Pressure gauges are tools used to measure atmospheric pressure. The pressure as compared to atmospheric pressure is known as gauge pressure. Gauge pressure is positive if the pressure is higher and higher than the atmospheric pressure. Gauge pressure is negative for pressures below the atmospheric pressure. Vacuum gauges and pressure meters are the names for pressure gauge. These are the images of categories. The next one is a valve. A device that regulates the flow of liquid or air by a pipe, duct, or other conduit, especially one that automatically permits just one direction of movement. These are the images of those. And next part of the presentation will be continued by Bruno. Thank you.
I'm Bruno Camargo again, and I'm going to explain the algorithm that we use the Python code and was developed for this project. So the first step was to use the online website tools MakeSense.ai to provide the equipment label. And we have one feature here, for example, where we highlighted the pump inside the engine room. Then, since the code itself is very big and very huge, with a lot of lines, we summarized all of the steps here from step A to N. So the first one, we needed to package all of the images in a zip file. Then we developed an algorithm to do the unzip of the images file. And it's necessary to convert all of them to the JPG format. And then it's important to check the number of images and the XMLs they are having a match. We have a routine developed to install the XML routine, and then another code to find out how many categories is there in the file. Based on that, we are going to copy the images to train and insert them in a folder for test. Another resource used is a code for image augmentation with several sub-steps inside. Then it's important to make load of the images and then training and test these images. There is another routine named 51, and then we need to create the JSON for training and test the images. The next one is install the dependencies, import the libraries, do the trainings, and prepare the registries for the database. Finally, we did the tests and the evaluation of the algorithm. And then on the final step, it was the download of the final model. As results, we chose one equipment here, the heat exchanger, to explain. And as we can see, we got a good image detection for this case. On the right side, we have two graphics that shows the percentage of images based on the width and height. Now I'm going to hand over the conclusion to my colleague.
Hi everyone, this is Vikas, one of the group member. So to conclude, we have developed an algorithm to identify objects that are present in a closed space by using image analysis process. With the help of an online tool called MakeSense.ai, we have generated trained images using algorithm. Then these trained images are compared with the real images using the algorithm we have developed to know the percentage of similarity that helps the algorithm to identify the objects. Thus, by using this software, we were able to identify the large equipments that are present in the deck 4, 5, 6 of the hull engine. It is very difficult to identify the small objects, but on further development, it is possible to identify the small objects though. Therefore, it is important to study deep learning and image analysis to develop applications in the construction domain that helps to reduce the cost of construction and save time. For example, these the deep learning and image analysis can be used to understand the health of the buildings, measure the area of the construction project, etc. So that without a field worker, the work could be done. So that helps to reduce the cost and also save time. And the references we use the reference we have gathered the information from R. Sachs, A. Perlman, R. Burke theory, like the paper, and D. Goldberg, G. Ong, L. N., L. Wang, M. Raphael, C. Coach. These are all the papers we have gone through to do this project. And thank you.